Hello everyone. Hopes all of you are well. Today I bring very interesting topic to all of you, system suitability. So the system suitability requirement I have divided into two parts. First part I will discuss about the different system suitability parameters, what are their limits, what is the formula to calculate them, and in which method we have to use this. We can use these system suitability parameters. And second part I will discuss about the whatever the acceptable changes we can do in any analytical method to achieve the suitability. The method is compatible method. So in the first part I will discuss different system suitability parameters. So what is system suitability? Actually, when we are starting any system, whether it is GC, HPLC or some other technique, we have to inject the system suitability. Means we have to confirm what are the system we prepared. System means what are the mobile page we prepared, what the columns we are using, what is the instrument we are using, how is their performance, whether they are working proper way or not working. So to ensure all these things, we have to inject the system suitability. So to check the system suitability, we have to inject different SNED preparation. Sometimes we are injecting the peak identification solutions, sometimes we are using the impurity mixer, sometimes we are injecting SNED solution, sometimes we are using the dilute SNED to check the signal to noise ratio. So these are the different system suitabilities standards that we are injecting the HPLC, GC or other techniques to understand the performance of the system. So here are the few parameters which we can choose in different method based upon the test. Suppose when we are checking the chromatographic purity or related substances method, so that time we can check the resolution between two neighboring peak. And when we are tailing, also we can use in the related substances method, purity method or assay method, especially we are using tailing. Theoretical plate also we are using there. Percentage RSD of the response means repeatability. Means how our injector part is working, how we are getting the response, whether response are reproducible or not. So we can check the percentage RSD by injecting the sinners and percentage RSD of the area we can determine. Signal to noise ratio, we have to inject the dilutioner to check the sensitivity of the system, whether the system is enough to measure the small peaks or not. Peak to value ratio, that is alternative of the resolution when peak are not separated each other, that time we can check the peak to value ratio. So here first parameter, that is resolution. Resolution indicate how the two vicinal means neighboring peak are separated from each other. For good separation, the value of resolution is 1.5. Here, there are the two peaks. If we see here in the chromatogram, peak 1, peak 2. So, peak 1, it is eluting at the retention time TR1. And peak 2, that is eluting at retention time TR2. And if we see here, first peak width, that is VH1, means at the half height peak width. VH2 is the peak width of the second at half height. So when we want to check the resolution, so we can use the formula RS equal to 1.18 into TR2 minus TR1 upon WH1 plus WH2. Here TR1 and TR2 are the retention time of the peak 1 and peak 2 respectively, and WH1 and WH2 are the peak width at the half height, means half height of the peak. width at the half height of the peak, that is a WH2. So by using this formula we can calculate the resolution, but nowadays machines are calculating the automatic resolution. So if resolution between two peaks is more than 5, we can say system is good and peak are well separated. But if resolution is lesser, then peak are not separated to each other. Next system suitability parameter, that is symmetry factor. Here that is symmetry factor means how peak is symmetrical. The symmetry factor of a peak, also known as the asymmetry factor or tailing factor, it is calculated by using the formula. So this is the peak here. If we want to check the asymmetry factor, then A is equal to W 0.05 means 5% height. Here this is the 5% height. 5% height पे जो peak की width हो गई W हो गया. And 2D means if we see peak starting from here and it is going up to here, this is the middle part of the peak here. So from the point where peak is starting and the height where the peak is at the maximum response, that is D. So asymmetry we can calculate by using the W at the 5% height upon 2D. So if A is more than 2, then peak is tailing. If A is less than 1, peak means peak is having the fronting. The tailing value for the any peak, that should be less than 2 in blended substances method or any other method. And it is giving the information how the column performance, whether the column is working good or not good. If column is not working good, then it will be the more tailing. Similarly here, the first slide also, if column is not working good, then peak will not separate to each other. Similarly here, if column is not working good, then peak symmetry will not come good here, peak will give the more tailing. That is the reason these two parameters are too much important. Next parameter is the plate number. Plate number means how the peak is sharp. If column is new, then it will give the good theoretical plate. If column performance is not good, then it will not give the good theoretical plate. We can calculate the plate number or theoretical plate by using the formula n equal to 5.54 T half upon WH square, where T is the residence time of the corresponding peak of the component and peak W is the peak width at the half height, means half height पर जो peak का width है, that is W. Next is the signal to noise ratio. Next is suitability parameter. Signal to noise ratio means signal to noise ratio provide the information about the sensitivity. Sometimes when we are doing the analysis on HPLC and lamp is not good, HPLC lamp is not having the good performance, means that is lamp is aged, that time you will not get the good response. Or sometimes when some problem in the detector part, that time noise will come more. So noise coming more means you will not go at the, will not achieve the good signal to noise ratio. So that the value of signal to noise ratio should be 10. So here next parameter is the peak to value ratio. When two peaks are not well separated to each other, base to baseline, that time we can use the peak to value ratio to check the separation between the two peaks. Suppose if you see here, this is the peak one here, that is not separating from the second peak, base to base here. So that time we can choose, this is a peak height, HP. Here this is the height peak peak height is the peak value here. This is a valley height here. So that time we can so if you want to calculate the peak to valley ratio, that this height divided by this height, you will get the peak to valley ratio. Next system suitability parameter is the precision. Means we have to, in this parameter we can check how the injector portion of the HPLC or GC is working. If it is working fine, then we will get the good percentage RSD value of the peaks, different peaks. So to check the repeatability, we have to inject the standard at the spec level, and we have to check the percentage RSD value. Suppose when you are injecting injection 3 injection, 4 injection, 5 injection or 6 injection, based on the number of injection of the standard solution, we can fix the limit of the standard deviation. Suppose if we are injecting 3 standards, then the percentage RSD value of the area should be less than 0.42 percentage. When you are injecting the 4 injection of the standard solution, that time the percentage RSD value should be not more than 0.59. And when you are injecting the 5 injection of the standard solution, so that time percentage RSD value of the area of the area 5 injection will be 0.73. When we are injecting the 6 injection, then percentage RSD value of the 6 injection is 0.85. So this value also depend up on the percentage B. Means suppose SA value is 98 to 102, means higher value 102 minus 100, there is 2. If percentage, if the SA value is a 97.5, then we can choose the difference B by the 100 minus value. And when it is the 3, it is 3, this type of area. So percentage RSD value will be different. So here this is the table we can use here, and we base upon the requirement, based upon the standard or limit of the particular test, we can fix the percentage RSD value of the precision. So hopes this my explanation about the system suitability parameter you have understood well, and it will be helpful for all of you. And in the second video, I will give the information what are the allowable changes we can do in a method to achieve the system suitability in a method without doing the further validation. So I will discuss there how much percentage difference we can do in the pH value, or how percentage composition of the molecule we can alter, or how the column length we can alter to achieve the system suitability, so that we have not do the, so that we no further validation is required. So in the second video I will discuss these parameters. Hope my video is useful to all of you. If you like this, if you like it is interesting for you, then you can like and subscribe, like my video and subscribe my channel, and share to the video to your friends. Okay, bye, thank you.